Hello and welcome to the next video in the series introducing HyperFlow AI. In this video, we will dig more deeply into the building and running of flow graphs in HyperFlow, constructing an agentic AI application as we do so. Agentic apps typically organize multiple LLMs into a workflow where each takes on a specific role in the larger application, effectively acting as agents performing their assigned roles, hence the term agentic. Here, we will build a two-agent content generation flow, with one LLM tasked with generating a requested image, and the other helping the user review that image, constructing an improved prompt that is looped back to the image-generating LLM to create an improved version. We go around this loop until the user is satisfied with the result. Okay, I've created a new flow graph and opened it in the editor here so we can start building it. As shown in the first video on building and running flow graphs, you add nodes by dragging them from the node tree here. Let's see, we will need two call LLM nodes, the image generator and the image reviewer. We also want to get an initial image request from the user. Now, you can also add nodes from the editor right-click context menu here, which I'll use for this node. And we'll also want to give instructions to the reviewing agent so it knows why we are sending it images to look at and what we want from it. So let's add an instruction node here. Okay, so I'm going to wire up the process flow first. Notice that HyperFlow made the first node we dropped, the start node, but we want the user input first. So right-click on the input node and select Set as Start Node. And so now the flow will be first get user input, then generate an image, review the image, and loop back to generate the next refinement. As it stands, it will loop forever. So we can add a loop controller and set the max loop count. The top exit connector here is the loop continue, and the bottom connector is the loop end. Let's loop the continue exit around to the entry connector on the image generator. Let's set the loop count to say 3. You'll notice when I hover on the parameter, a lock button appears above it. This is actually a key feature of working with HyperFlow in developer mode within the IDE, and that is locking and unlocking parameters. If a parameter is left unlocked like this, each time the flow reaches its node, the IDE will stop and give the developer a chance to adjust the value. This is handy if you want to try different settings each time around. But if you want the flow graph to just run the node without stopping, you lock the parameters and the node becomes a kind of preset. I'm going to do that for this node now. Locked parameters have this gray shading and can't be changed unless you unlock them. So now the flow will run around this loop 3 times and stop. We'll improve on this shortly, giving the user a chance to control the looping. While we're at it, let's set the image generator node's role. You'll notice the node's default parameters have several locked. This effectively presets the node to be a chat or text generating node, which is often the role you want. Let's unlock it and make it an image generator. You can see we can make videos and audios as well. HyperFlow is a fully multi-modal AI development environment. When we shift to image generation, the available LLM services down here updates to those that provide image generation. Okay, let's start wiring up the data flow. The initial image request prompt should go into the user prompt input of the generator LLM. Any media it generates is available on the generated content output connector. So let's connect that to the content input of the reviewer LLM. We want the instructions for the reviewing LLM to go into its instructions connector, and the improved image prompt it generates is available on the generated response output. We want to send that back around as the next image generation prompt. You'll notice if I try to connect it up there, it won't allow it. This is because in the current release of HyperFlow, a dataflow input connector can only have one input source. This will be improved in upcoming releases to allow multiple inputs. So for now, we can use a merge inputs node to help here. Let's move things around a bit and add that in. Now I have the original user prompt going into input 1 of the merge node, and we'll connect up the generated new prompt to its input number 2. Merge input is a very versatile node which will be explored in more detail in later videos, but for now it is passing through to its data output connector, the most recent data that came into it. So first the original user prompt, and then subsequent loops will pass the latest image prompt generated by the reviewing LLM. Now, the image generating LLM by default will generate an image according to the prompt it is given, so it doesn't need any special instructions. But we need to give the reviewing LLM some instructions on how to carry out its task. Something like this should work for now. Review the user prompt as a request for an image and analyze the supplied image relative to the user's original request prompt, generating suggested improvements in the form of a detailed prompt for DALL-E 3. Don't necessarily repeat the structure and content of the supplied image. Try variations that might fit the original prompt better. You must output only the detailed DALL-E 3 prompt, no other comments or critiques. Okay, let's lock it down for now as well, although it's likely you will want to experiment with these instructions. Writing effective instructions is often the most important part of getting generative AI apps to work well, and we will devote a series of videos to best practices in this aspect of prompt engineering. I'll touch on one other advanced aspect of HyperFlow flow graphs that we will also explore in more detail in later videos. And that is that some nodes that supply data, like the instructions node in this case, do not need to be wired into the process flow with purple wires. These are called pure data nodes and will be run on demand by the nodes they supply input data to. Each time the reviewing LLM node runs, it will automatically ask any pure data nodes connected to its data inputs to run. And they will do the same if there is a chain of pure data nodes supplying one another. HyperFlow supports mixed data flows and directed process flows in the same graph, a very advanced and distinctively unique capability. Recall in the review LLM's instructions, we asked it to refer to the user's original request. So let's give it that as well. Output data connectors can feed as many data input connectors on other nodes as you need. While most of the time the automatic wiring placement works well, sometimes it's hard to see where the wires go, as in this case. To check, you can click on the connector label at either end like this to highlight all the places the data goes. So here the user prompt goes to both the input of the prompt merger and the prompt input of the reviewing LLM, so it can refer to the user's initial request. You can also move the wires around in limited ways by hovering over the middle of a wire and dragging the move arrow that appears to drag it where you want, like this. I will often tweak placement after a wiring is done to make things clearer. Okay, I think we're almost ready. Let's take another walk around the node's parameters before we run it, in case we can set more things up before the run. User input looks good. Merge inputs is passing text, sending on the most recent data, and we only need 2 merge inputs. You can merge as many as you like. Let's lock this now. We likely won't change it again. There are all locks buttons at the top here, so I can lock all the parameters with one click. The image generator call. Let's select OpenAI and DALL-E 3 as the model. Those red outlines mark the parameters that must be set. The others have either useful defaults or are locked. In media generation mode, the generated media is stored in the project's asset store automatically, so you can retrieve it at any time. And you can give it identifying tags down here. Let's say John's cool images. The reviewer LLM stays in chat mode. And let's pick a multi-modal model that can analyze images, say OpenAI GPT-4o, and lock that down. Ready to run, I think. As it stands, once we start, it will continue automatically for the 3 loops since we've locked down all the parameters. It might be useful to pause and look at the revised image prompt on each loop. So let's set a breakpoint at the image generation agent by right-clicking on it and selecting Toggle Breakpoint. This marks it in red, showing that the flow graph will pause at that node, waiting for us to get it going again. And this time, let's run it in a test chatbot so we can see what a user might see. You do that by selecting Run in Chatbot up here. This brings up the HyperFlow IDE test chatbot on the left. Even so, we are still running in developer mode, and so we get the parameter panel and run session log, same as before, so we can see in detail what the flow graph is doing while interacting with it in the test chatbot as a user might. The parameter panel knows the test chatbot is in play and directs us to provide the initial input prompt there. Let's give it an image request. Say a penguin wearing a red coat skating happily on ice. As I mentioned, with all the node's parameters locked down, the flow graph would just keep running until the loop controller stops. But since we put a breakpoint on the image generator node, HyperFlow has dropped into a single step mode for us there. You're in this mode when you see the step controller buttons up here, and the session log will say waiting on next step. Pressing step will run the node it is paused on and stop on the next, so you can step your way through the flow graph, inspecting info in the session log step by step. Hitting continue will set the flow graph running again until the next need for input or breakpoint or flow graph end. We can see here the output of the merge inputs node is the most recent data it has seen, in this case, the user's initial request. We'll check this again next time round. I'll press step this time and the image generation request will be sent to DALL-E 3, which usually takes about 10 to 15 seconds to generate an image. Yep, here's its first attempt. Not too bad. HyperFlow is now sitting on the instructions node for the next step. Why is that? The process flow line goes to the next call LLM node. That's because the instructions node is wired here as a pure data node, and it will be run by the node in the process flow that needs its input, as I mentioned earlier. So we did indeed step on to the call LLM node, but it said it wants its instructions input, and so HyperFlow runs that as the next step. Note that HyperFlow will only run pure data nodes on demand like this. If a node is wired into the process flow in any way, HyperFlow assumes it will be run in the process flow at the right time, and so will not run it on demand. This lets you control exactly the ordering of node running when you need it, but not worry about it for pure data supplying nodes, which makes wiring much simpler. The pure data flow capabilities of HyperFlow are fully complete and recursive, so you can build entire flow graphs with no process flow and just start at the node producing the result you want. The connected pure data nodes will run as needed. Let's set things running again by pressing continue. The reviewing node now runs, looking at the instructions from the instructions node, the image from the generator LLM, and the original user request. You can see all that in the composite prompt display here in the session log. The review is generated and shown here in the session log. The LLM has expanded the prompt and added in a little creativity. This will be used as the improved image generation prompt. HyperFlow keeps going and loops back around to the image generator, pausing again because the breakpoint is still in place. We can see now that the output of the merge inputs node is indeed the revised prompt, the most recent data it received on either of its input connectors. Let's step once more to see how DALL-E 3 responds to the upgraded prompt. Penguin certainly seems happier. Okay, let's run the thing uninterrupted for the remaining loops by toggling off the breakpoint here and pressing continue. We see it's generating more images and eventually gets to end of run because of the max loop count limiter. Let's review the session log. All of the steps are recorded in detail for run analysis. You can download the images by right-clicking and selecting Save Image. Oh, notice the end of run finished with a suggested prompt that was not used. That loop should probably have ended here after the image generation. Let's quickly fix that, but instead of a loop counter, let's arrange for the user to decide whether to keep refining. We can do this with the Choose Path node, which lets us set up branching in the flow, displaying buttons for the user to select which path to follow. For the Choose Path node, we'll offer two paths: keep going or stop, something simple for now. The top exit connector is the keep going path. The bottom connector is the stop path. When the user chooses stop, there's no process flow out of this connector, and so the whole flow graph stops. Now, this will be a common development pattern: building and running a flow graph, analyzing the session logs, back to the editor, improving the flow design, prompt engineering, and running it again. As an example of this refinement process, I thought an interesting variation would be to allow the user to engage with the two LLMs, offering extra guidance if it might be useful. I have this variation in another project. So let's go back to the projects page and select it. Taking a quick tour of this mod, you can see I've upgraded the Choose Path node to show three options, allowing the user to either enter a suggestion, just keep going around the automatic refinement loop, or stopping. The user refinement option goes along this path, asking the user for their suggestion, passing it and the original request into a data transform node, which is set to blend the two in a simple template. So the reviewing LLM sees both the original request, which comes in on input 2, and the user's new suggestion on input 1. I won't go into detail here, but the data transform node is very powerful, even allowing custom Python code, and there will be a video dedicated to its use shortly. The keep going path bypasses the user suggestion input, going straight to this merge input node, which will pass on either the original request or the blended request to new suggestion, depending on the path choice. We'll make this flow graph mod available as a download and leave it for you to try for yourself. But we'll wind up this video now, re-emphasizing the point that you can build almost any kind of AI workflow with HyperFlow AI. And we look forward to exploring more of these in other videos in this series. Thanks very much.